Let's go ahead and get started on finding the area under this curve, f of x equals 2x minus x squared. We're going from 0 to 2, looking at 4 subintervals. Alright, well, let's go ahead and get started with A, the graph. Okie dokie, I know that the graph looks like this because I found the x-intercepts, and I can use negative b over 2a to determine what the vertex of the parabola is, or I can know that, well, right in between 0 and 2 is 1, which is the axis of symmetry, so plug in 1, and that gives me the coordinate point of the vertex. So here we have part A. Now we need to find B and C. Okay, so here I have RRAM, and remember that RRAM represents the right rectangle area method, so I've pulled up the right hand corner of the rectangle to the graph, and I've found the area of each one of the rectangles. So we have 1/2, which is the base, times whatever the height is, and I plugged in the x value to determine what the y value is, which gives me the height of the rectangle, and multiply base times height to get the area. I added up all the areas of the rectangles together and ended up with 1.25. So now I have to figure out what LRAM is equal to, and then average the two areas together. Okay, so here we have LRAM, and I have the intervals, 4 separate intervals, and I found the area of each one of the rectangles. So the first one here, we don't have a rectangle. The second one here, we pulled up the left-hand corner of the rectangle, got an area of 3/8, pulled up the left-hand corner of the rectangle to that, and we got an area of 1/2, and then last one here we got an area of 3/8. So we add them up, and we get 1.25. Well, that's the same thing as RRAM. And so if we average them, we're just going to get the same thing. Alright, let's move on to the next problem. We want to find the integral by computing the area. From 0 to 5 for this function, square root of 25 minus x squared. What the heck does that mean? Well, you could just plug it in your calculator and you'd see a half circle, but let's know why the calculator does what it does. If I set this function equal to y and solve for x and y on the same time, first thing I'd do is I'd raise both sides to the power 2, and then I'd add x to both sides, and that would give me, that's the equation of a circle centered at 0, 0 with a radius of 5. So if I'm computing the area, first thing I want to do is look at the actual circle, and I'm not pausing it this time, so sorry to make you watch me do the drawing here. Here's the circle centered at 0, 0. And we want to find the area of the circle from 0 to 5, which means we're just looking at this particular area, right? And so that means we're going to find the area of the circle, which is pi r squared, so that's a 25 pi, and then we cut it into fourths. And that's the area from 0 to 5. Alright, so the next one we want to do is we want to find the area from 0 to pi for sine x plus 3, and then we want to find the area from negative 2 pi to pi for sine x plus 3. And once again, we see that in the directions it says it can be shown that the area enclosed between the x-axis and one arch of the sine curve is 2. So I'm going to draw a picture for us here. I will pause this time. Okay, so we have this graph here, and thankfully we have the same thing within the parentheses, so I could just tackle this all with just one standing graph. And I want to find the area from 0 to pi, and I find that area from 0 to pi like so. That area is 2, and this area here, this rectangle, the area of this particular region is going to be the length times the height, and the height is 3, the length is pi, so we have a 3 pi there. I also want to find the area from negative 2 pi to pi, so I'm going to find this area here, which once again is 2, and this area here, which once again is 3 pi, and so I have to add all this together, which gives me a 6 pi plus 4, which is the area added up. Okay, so we want to find the integral, assuming that k is a number between 0 and 5. Alright, so we know we have this line that goes through right at 2, and our slope is up 5 and over 1. So we have this line. Oh, that's a bad line, huh? This line. That's a bad line too. We have this line like so, and it's kind of difficult because we know that we're finding the area all the way to 5. So we're finding the area here. We just don't know where to start. Does k start 0, 1, 2, 3, 4, 5? We just don't know. So what I want to do is I want to find, hold on, this guy outside's bugging me. Okay, so I'm going to use the area of a trapezoid to find the area from k to 5 for 5x plus 2. I know that this base right here is found when I plug in 5. 5 times 5 plus 2, that's going to give me a 27. This base, I'm not really sure of what it's going to be because k is a variable between 0 and 5. But I do know that this base here, I'll find it by plugging in that k value, whatever k is. So that's a 5k plus 2. This right here, which is the height, is some distance from that's less than 5. In fact, we take k away from 5 to determine what that distance is. So we'll call this one the b1, this one the b2, and this one the h value. So we got to plug that into the area of a trapezoid formula and then solve. Alright, so I started up there at the top by writing the area of a trapezoid. I plugged in, I added b1 and b2 in my head, and then I multiplied, and then voila, there we have the area. Whatever k happens to be, we just plug it in and it tells us the area. Let's move on. Alright, we want to find the limit algebraically. So the thing about this problem here is that if we were to plug in 3, we would have a division by 0 problem, and so we need to solve this, simplify this algebraically, which is pretty easy to do. And goodness, Mr. Reinheimer, why didn't you push pause? So sorry, forgive me. And now we don't have the division by 0 problem. We can plug in 3, and that gives us 6 over 8, which is going to reduce to 3 over 4. So the limit as x approaches 3 is 3 over 4. We have a hole in our graph at 3, but if we were to actually visualize this on a graph, we would see that we do approach this point, this y value of 3 over 4, even though there is a hole right at x equals 3. Alright, I'm running out of time here. Okay, so on this one here, we need to use the fact that the limit as x goes to 0 of sine x over x is equal to 1, along with the limit properties to find the limit. Show the work. Okay, so we have the limit as x goes to 0 of x plus sine x over 2x. So let's use some algebra to break this apart. Okay, so the first thing I did is I broke apart, so we have x over 2x plus sine x over 2x. You know, that's going to give us x plus sine x over 2x if we add it up. And then from there, using the properties of limits, I broke apart with 2 limits in this next step here. And then after that, I actually pulled the 1/2 in front of the limit as x goes to 0, which is another property. And at this point here, I have a x over x here, which just is going to give us a 1. And then I have plus 1/2 times. Remember, the limit as x goes to 0 of sine x over x is 1. And so we are left with a 1/2 plus 1/2, which is just equal to a 1. Alright, next one here, we're going to look at the graph. Okay, so here I have my graph, and this first problem says the limit as x goes to 2 from the left-hand side. So as x goes to 2 from the left-hand side, our y value goes down to negative infinity. That's A. As x approaches 2 from the right side, our y value goes up to positive infinity. As x goes to negative infinity, our y value goes to 0. As x goes to positive infinity, our y value goes to 0. We have asymptotes at x equals 2 and y equals 0. So the vertical asymptote is at x equals 2. The horizontal asymptote is right at 0. Alright, last problem, everyone. We're done. Alright, so A8, we have the limit as x goes to 1 from the left-hand side. So as x goes to 1 from the left-hand side, looks like we're approaching 2 as x approaches 1 from the left side. As x approaches 1 from the right side, it looks like we're going to this y value of 3. There's no real point there's no y value of 3 really. There's a hole there, but we are approaching that value. And because we don't approach the same thing from both sides, the limit as x goes to 1 just does not exist. So I'm going to just write a DNE there. And I hope this was beneficial. See you in class. All right.